let's get this party going. Okay, so hi, we have four friends joining us online, and we have, sorry, your name is Pang. Okay, hi, right. So right off the bat first, my name is Teacher Jason. You can call me Mr. Jason, Mr. Pang, whichever. As long as you get my attention, I will be able to answer your questions. And if you're moving along, right, something I like to do, I like to do a lot of drawings and writings. And as you move along, it would be great if you can follow along with my writing for us to just learn together better. Okay. But if not, let's get this going. Okay, so we're gonna start with the chemistry portion, right? There'll be some summary notes at the start, and then we'll go into some questions together. But I would really love to focus on the questions portion a little bit later on because that's what we are doing. We are revising and practicing. We're not learning new stuff here. But hey, if I manage to share with you something new, that'll be excellent as well. Okay, so Emma versus AR. The letter M, letter A, that's just what it stands for, right? Molecules are made up of many atoms chemically bound together. Okay, fairly straightforward. So, okay, work with me on this, right? So, chlorine exists as a diatomic molecule. So, di means two atoms. That's what we're looking at here. So, two chlorine atoms. If each Cl, if you look at this, if I were to color code this for you, two chlorines. So together, 71 is Cl2's Mr. Okay, so overall mass. Okay, it's just like if a fruit basket is one apple, one orange, how many fruits is there in the basket? Two lah. Like also do it together like that. Okay, but what if it's a more complex one like sulfuric acid, which is H2S4, so on and so forth, right? All you need to do is just do your proper multiplications and additions. Keep it simple. Okay, do not memorize any of these. All these things you can get from your beloved periodic table. Straightforward. Okay, moving on. Okay, this one must memorize. Okay, more calculation cannot run away one. Okay, must remember. Usually we look at it in terms of triangles. So if this is better for you, you can remember it in terms of triangles. For example, how would this be represented in a triangle? It would just be that's it. So the way to use the triangle is to cover up the thing that you're trying to find. So if I want to find mole, I cover up mole. What am I left with? Mass over mR. Right? If I want to find mass, I cover mass, I will have mole times mR. That's it. Okay, every single one of these can be converted into triangle as well. And if there's something you prefer, go ahead and try and triangle it out. Okay, if not, we will leave this in a way a formula sheet for you over here. So let's have a look at this. Magnesium carbonate is strongly heated, it decomposes as shown. As we move, as we progress towards more complex questions, you may even see questions where they don't give you the equation. And that's something that we must be familiar and comfortable coming up with as well. Okay, so magnesium carbonate, MgCO3. All right, so we're looking for formula mass of magnesium carbonate. So we use the word formula mass when we are looking at the mass of an ionic compound. We will use the word molecular mass for what kind of compound then? So relative formula mass for ionic compounds. Relative molecular mass, what kind of compound then? Other than ionic, it's the easier one. This one, covalent molecules, right? So for example, what are some examples here we have? Carbon dioxide, water, right? What are some examples of ionic compounds? Other than magnesium carbonate over here, you have sodium chloride, your hydrochloric acid, right? So please keep this in mind. Everything that chemistry is very cumulative. It adds up all together. Okay, right? So Molecular mass for covalent, formula mass for ionic. And that's the only difference, the name. The method of calculation is the same. So if I were to tell you, technically you have a periodic table to refer to. Magnesium is 24, carbon is 12, oxygen 16. That's all you need. Because there are only three different elements here. How would you make your calculation here? There's only one magnesium, so 24. There's only one carbon, plus 12. Plus 3 oxygens. Put your bracket in. You have your answer. Yeah, maybe complete that, please. 84, is it? Okay, now, for unit on time. Don't have, Now, let me share with you. There's a reason why we have this word. Relative molecular mass, relative formula mass. This means the number that you have, the value that you have, is always compared to something else. So therefore, it is just, in a way, you think of it as a ratio. And for your level right now, it's always understood. Doesn't matter, 84. Okay? Yeah. Okay. And all right, so we have this already. Now we're looking at number of moles. We have, what quantity is this called? Is this volume? 0.42 grams. What kind of quantity is this? And what kind of quantity is this? Is this volume? 0.42 grams. Volume would be your CMQ, DNQ, or something. Yes, this is mass. If I have mass, I want to find number of moles. We will just recall your triangle. Yes. That's it. Right? I want to find number of moles. Mass over MR, right? I got MR now. Yeah, we just found it in part A. Therefore, now a big part of chemistry is to be clear in our workings. Presentation is very important. Do this. Oh, it's lagging. Okay. Number of moles of MgCO3. This is very important. Please do not just jump straight into your workings, especially when next time you will not be given A, B, C. Let me tell you, next time they will just give you this number and ask you straight for this. Okay, wait, my screen is lagging a lot. Let me. So go ahead and do your mass over molar mass. 0.42 over 84. Is it correct? Now, we want carbon dioxide though. This is where our equation comes into play. We have the number of moles of this one. I want to find the number of moles of this one. How are they related? How are they related? A Arian, you want to help me with this? How is MgCO3 and CO2 related? Arian, are you there? How do we use the equation?
I don't know.
You learn more calculation already not?
Yeah, but I cannot That's why I count.
What do we use the equation for? Give you a clue.
Ratio.
Ratio, absolutely. Look at that. You know one. Okay. Don't doubt yourself. So therefore, you need to find. You're gonna find our ratio first. If it's a 1:1, therefore, number of mole is going to be the same at 0.5 moles. So 0.05, is it? Kathleen says 0.005. Hey, you, why you tell me correct? Hey, big difference leh. Thank you, Kathleen, for pointing that out. Cannot just see got 5 correct already. Not wrong. Right, and therefore it also affects this one. Well done, Kathleen, for catching this. Okay, so now that we have arrived at our correct number of moles, 0.005, we want volume of carbon dioxide. Now, carbon dioxide exists naturally as a gas. This is where the easiest trick comes into play. When you want to find the volume of a gas, the triangle that we need to be using here is how is it different from this triangle? How are these two triangles different? Okay, that is to find number of moles, mass over molar mass. To find number of moles, volume over 24 dm cubed, which is what we refer to as so mass over molar mass, volume over molar volume. Therefore, as I shared before, make sure you are clear with your headers. Okay, this is a number that you must memorize straight up. Okay, because it is a very easy shortcut. All gases, all gases at room temperature. If I have 1 mole of it, you will always occupy this volume. So then if I do the opposite, I say, oh, I have any gas, random gas X. It occupies 24 dm cubed. How much gas X do I have? 1 mole. It's always the same. Okay? Right? So this tells me we can take this opportunity to remind ourselves any gas at room temperature one mole of any gas at room temperature will always occupy 24 dm cubed. Okay, so how do we use this triangle now? I want to find volume. I use mass times dm cubed. Mole times dm cubed, sorry. So I have 0.005. So here we have dm cubed. Do we know how to convert dm cubed? This one is actually okay. So usually questions will want us to leave it in cm cubed. Hence, okay, 0.005 times 24,000. Is that 24,000? 3 zeros No, press 3 Has it correct? Awesome. Okay, that's it. So I just want to make sure we understand during our initial practices even in school as well, you will see guiding questions. Like I said just now, it's very easy for them to give you this number, give you this equation, straight away ask you for this. And then they say 4 marks. Like that lor. So through these practices, A, B, C, D, you need to be able to tell yourself next time. Next time when you see this question, I need to be able to do all these steps first before I get to my final answer. Okay? Right? So that's what we're looking for. And let's move on. Question 2. We have lead 2 nitrate. Now I have this. So I'm going to color code it properly. The number of moles of nitrogen gas produced. Oh, we're talking about gas again. Did I just share with you all? Did I just remind you of something about gases? It's very unique to gases only. That's it. In your question, what is the volume of nitrogen dioxide produced? What's the volume of nitrogen dioxide gas produced? What did we just highlight? At the top. Yeah, NO2 is nitrogen dioxide. How much is the volume? Units. That's it, 6 cubed. So if this one is 6 over 24, I get the number of moles. Easy peasy. So again, please be conscious. This is 0.25. So I have the number of moles of NO2. Part B is asking me for PBO this one. What is the link? No. This is something that Arian reminded us just now. We use the numbers in the equation. Therefore, we start off our workings with I only have NO2, so I must start with NO2. I want to find PBO, therefore PBO. Looking at my equation, what's my ratio? Okay, 4:2. Simplify it, 2:1. Hence, number of moles of. So if they are 0.25, 0.25 is 2. What is 1? Very good. Do not forget our units. Is this what the question is asking for? Question is asking for mass. So now I have mole. I want to find mass. What do I need to do? Excellent. That is the MR. Okay. That is 126. Okay. Is this your this spreadsheet got a period table? Yeah. Let 207. Okay, so make sure you get your brackets out because multiplication, I want to make sure I multiply the whole thing. So PBO is 207 plus what? O is 16. Yes, so like I said, it's very important for us to do this. Why? Because remember just now I said that your questions next time is just going to be like one line and 4 marks. Then in this entire page, if all you do is just all these kind of things, very quickly you're going to get lost because you do not know what those numbers mean anymore. Imagine now your answer is just your paper is just like that. What does it mean? Correct or not? Maybe at the spot when you write down, you may know. But let's say if it's a difficult question, which it will become in future, then you're like, maybe I skip now, I go other question first. You want to save time, right? Then you come back to this question, wow, lost. You have no idea what you just wrote down. Which is waste more time, isn't it? So let's just spend a little bit of time right now and make sure we can get everything right. Answer will be what you need. Gram lah, what do you need? Mass lah. Okay? And always leave it as such. Now, suddenly, randomly, oxygen produced, yes, but it's not related anymore. Question 3, Zhan. But can I just share with you what does RTP stand for? Yes, that's it. RTP. And this is important because on the previous page, we wrote this down. Any gas at room temperature occupies 24 dmq. Okay, so this rule, 1 mole 24 dmq only applies at room temperature. Okay, come. So our last next question. Oxygen gas volume. Do I need to care about oxygen gas being like this? Then the MR equals to 16 times 2 equals 32. Need to care or not? Volume, gases. What triangle is this? That's it. So if I want to find volume, mass is not here, here, or here. So how? What can I use mass to do? What can I use mass to do? Easiest. Start with mass over what is molar mass of oxygen? Oxygen gas is O2. Then what is volume? So I find this one first. No, what am I doing? If I leave it at dmq, that's it. Excellent question. When do we leave it as dmq? When do we convert it into cmq? If the question specifies. If the question never specify, you're free to use either one. As long as you convert correctly. But usually, you choose cmq because it is a scale that we use more often. Okay? Okay, 2 questions done so quickly. Easy peasy. Can follow so far? Okay, so the purpose of this is not just, excuse me, to be able to follow, but hopefully after this, makes you a little bit more confident to do it on your own as well, isn't it? Okay, now I have NaOH must be dissolved in 25 to prepare this. Ooh, look at this. This is a unit for concentration, yes. But how do we read this? Mole per dm cube. Mathematically, again, just be sure we understand that this is divided by, and that's it. So let me help you understand this better. The unit for concentration is obtained by, that's it. Make sense not? What does this mean? dm cube. This is a unit for what kind of a quantity? Is it length? Is it mass? Mass only got your gram, kg, all these kind of things. We just did this. This one is volume. dm cube, remember the gases? dm cube, cm cube. Eh? Okay. So then, this is 0.4. What is this? So if I plug in the numbers, 0.4 equals to mole I don't have. Do I have volume? Yeah, isn't it? What's the unit? What's the unit here? So how to convert? Very good. Rearrange this. Okay. 4 times 5. What do we get? 0.1. I see that you're not writing my headers. I see you're not writing my headers. Because this is not the answer. What's the question looking for? Yeah, look at that. Immediately, can you see why without the headers it's going to be very confusing? So I have number of moles now. I need to find mass. How do I find that? I have number of moles. I need to find mass. What do I do? Which triangle do we use? Okay, flip this one. Don't flip. That's it. So 0.1 times M out of NaOH. 23, 16, 1. Come, tell me. Huh? 4 is wrong. Cause actually don't need lah. But you must tell me grams. Okay? Yeah, friends at home, please make sure you're following along as well. I can't see you. I can't really ask you questions. I really hope they are following along. If any questions, please sound out and ask me. Okay, so really make sure we understand all this concentration thing, because concentration is like a level 2 formula kind of thing. Okay, question 5, I have a new reaction over here. I have an alkali reacting with an acid. You give me a salt and a water. Wow, got so many numbers, eh? Why not? Now, this belongs to this. So both numbers belong to NaOH. This belongs to who? Read the question. Required 23.30 cm cube. Read, continue. 23.3 cm cube of dilute sulfuric acid. So this is the volume of sulfuric acid. Right, your language must be able to understand as well. So question here is asking us for NaOH, which is the green one, number of moles. Can I find number of moles? The only information about the green stuff is volume and concentration. Can I find that?
Yes.
How?
Times the volume.
What times volume? Excellent. That's it. Is it 25? No.
Okay. Where I have convert?
The units, isn't it? Answer is very good. Thank you for double checking. Right? And so if I know that the number of moles of NaOH is this, part B. Straight away ask me concentration. Sulfuric acid is the one in orange. You ask me for mole per dm cube, which is concentration. So if you remember, we understood this properly already. Just now above we wrote this, right? So therefore they're asking me to find this. I need these two numbers. Do I have these two numbers of sulfuric acid? What is the dm cube? What's the volume of sulfuric acid? Do I have number of moles? In part A, isn't it? Look at that. So piece all these things together. That's it. So we have, do I have number of moles? Is 0.0125 number of moles of sulfuric acid? Is 0.0125 number of moles of sulfuric acid? What is this for? How do I find number of moles of this?
Oh.
Hang on, charcoal ratio first. Which one? Huh? Oh, question 2. Is that? That's why I say important. Can? So let's go. So by mole ratio, I have NaOH, H2SO4, 2:1. So number of mole of sulfuric acid is 0.00 6 6 1 2 5. Anyhow, what's this? What's the number? Correct. Oh, there's no one. So close. Wow, anyhow guess on it. Okay, question asking for concentration. Mole per dm cube means mole divided by dm cube. So over volume, what's my volume? Above they give me 25, isn't it? What's my volume? 23.3. But do I leave it as 23.3? Must convert it into dm cube. This brings me to Cannot 27. In all your chemical calculations, final answers in what's this?
Oh,
Okay. Final answers always in TSF, ah. Okay, so I have concentration in mole per dm cube. Question asked me to convert to grams per dm cube, and it is an equation on your first page as well. So what do I do? What's the molar mass of sulfuric acid? H2 is 1 times 2. S is 32. O4 is what? What is O4? O4 64. One oxygen is 16. All you need to do is okay, so what you're doing. And hence answer is because express the concentration. It's just like that. You want to write also can, but in this case, it's very straightforward like everything. Okay? But good that you caught it. It'll be good if you just always put it down. Because if there are no leading questions like this, if there's no ABC, then I will definitely write down over here. This one. Okay? We want to try now. We already did 5 questions together already. Your wheels are turning well already. Last question for more calculation. May I offer everybody 5 precious minutes to try this first? Try first. Okay? Hang on. First step is what? Yeah, we color code. These two numbers belong to who? Of nitric acid. Question asking for hydrogen gas. How? I only got info of this one. How to find this? In a chemical equation, we use our ratios, isn't it? This is a 2 is to 1. Why is it 2 is to 1? In the equation, no number means 1. So therefore, can I just 50 is 2 is to 1, therefore 25? Then this one, 0.25. Mole ratio, which I must find number of moles. Hence, my first step is volume of this is the volume of nitric acid. You use 24, is it?
No. 2.5 times 5 we don't know general. From years now.
Yeah, correct lah. Which is find number of moles, ma. Show me.
Just one.
No. Why is so many equal sign one? 0.5 equals mole over. Why got so many equal sign? Sarah, this one right? Remember this one? You're breaking this down. I want this part only. So if this thing this is 0.5. This right here is 0.5, right? The green color DM cube is here, right? Is 50 over 1000. Then you can find more, ma.
So it's not a
No, it's mole over DM cube. Okay, so number of moles here, how do I rearrange these three things? How do I put blue over here? What do I do with red and green? They multiply. So I have this gives me and mole ratio. Is the question asking for number of moles? Volume. So therefore, what do I do? You're at 24. I want to find volume. So you cover volume times. Question never specify any unit. You just leave it long. Less things for you to mess up, isn't it? So therefore, you will get this is exactly what I was saying. Question will just give you one sentence, 2 marks. You need to be able to think of, oh, first step. Oh, second step. Third step. Fourth step. To get your own 2 marks. Okay, so we are using all these guiding practices to make sure that we can have this habit of going through all these steps as well. Right? 2 marks. Next time, 4 marks, 6 marks. Don't be intimidated. Don't be like, wow, one whole blank space, 4 marks. Where do I even begin? You will actually always begin in the same few places. If the question gives you equation, go to find number of moles. If the question never gives you equation, find equation first, then go to number of moles. These two things are always the first two steps. Equation, number of moles. Equation, number of moles. Okay? Times 24 at the end. Claudia, is this what you mean? This part over here, number of moles of nitric acid is mole dm cube. This one is cm cube, right? So I must convert it to use it in the equation. Once I've done so, my unit is now mole already. I'm not working on dm cube anymore. So as I use it with mole, now volume of hydrogen gas produced, the equation is this part, this thing over here. Molar volume. This is not a conversion step, Claudia. This is a equation, a formula step. Molar volume, you can either express it as 24 dm cube or 24,000 cm cube. Okay, question never specify. So you take the easier way out lah. This one lah. Have I answered your question, Claudia? Awesome. Thanks for asking. Let's move on. Periodic table. We can use this front page as a good gauge for us as well. Very, very briefly. Group valence. Okay, just group valence electrons. Period. Electron shells. That's it. This is the most basic trend that we must not know. We slowly add on new trends and information as we progress. Everything on the leftmost, this one, your group 1 metals. Slowly, as you do more things, this will be in your mixed brain already. I don't like to memorize. Because even I also don't like if I see an entire list and someone tell me memorize, even right now I'm teaching so long already, I see it, I also sian. So I understand what you're thinking of as well. So therefore, instead of just like, okay, group 1, just memorize. May I offer you a perspective where keep on referring? Because that's how the brain works. Every time you refer, you must put in effort lah. You tell yourself, okay, let me try and remember this. Every single time you do this, you add on, strengthen that memory bit by bit. I don't need to like think it. Now like, okay, group 1, no MPBP. Close your eyes now. Group 1 what? Very stressful. I also don't like. Okay, so instead of die memorize, familiarize. At the end of the day, trust me, you'll be in your head one. Because when I was a student, I never memorized it. I just keep doing, keep familiarizing. And even for bio, later on you'll see, right? I teach 10 over years already. There are some things, right? I still have to think about it. So this allows my brain to think more, remember less. And that's the more important thing. Okay? So this one, just refer later. You need to know what alkaline metals are, what halogens are. And you need to know, this is what I said just now. All of them will be got 2 at the back. Right? Other than halogens, what other molecules exist as diatomic molecules? You also have your oxygen gas, hydrogen gas. Okay, these are common ones. Okay, blah, blah, blah. Okay, this one. Reactivity series. Chlorine. Oh, I don't want to use this. Chlorine. If you look at your periodic table, is higher than bromine. On this side, higher. Okay, what? Let's write this down. Okay, you find this You box this out or highlight the entire thing, either way up to you. I'm going to say reactivity. This way. On the other hand, this one, the arrow, could I also draw the arrow the other way around? So for this one, if I want to draw arrow down there, then it will be the other way around lah. If I point downwards, reactivity increases. Right? This side is D ma. If I point up, it's decrease. And point down is increase lah, opposite lah. If reactivity decreases as I go up, then lithium is the most or least reactive compared to francium. No, lithium is the least one. Right? So usually questions will state it in terms of down the group, which is this way. You need to be versatile, you need to be able to understand. If down the group is more reactive, up the group is less more. Makes sense? Easy, let's go. So therefore, the more reactive one can kick away. Can we see? It's kicking away. It's changing partners. This one is chlorine partner, another chlorine. They jealous of the Na and the Br. So I kick you out, I partner the Na instead. Not the Br has to partner itself. Okay, let's go. True false only. Across the period, you must understand. Period is the horizontal. Horizontal row. So when question says across, we are looking at this way, from left to right. So the easiest way is to look at the periodic table. You find something here. You find something here. Left side or right side is metal. Left side is metal. So if this side is metal, this side is not metal. Therefore, because you decrease. Metallic character decreases. Means left side is the most metal. Right side is the most non-metal. And that's exactly what we learned, isn't it? Okay. Are they arranged according to increasing mass number? Is this the thing that governs their arrangement? It is not. What is it instead? It is the proton number. What is radius? What is radius? What does radius mean? The math thing, isn't it? Radius is right. So atomic radius is the radius of the atom. So in a way, you can think of it as size. So does the atom increase in size down the road? So very simple. You know onion? You cut onion before. Onion got many what? Layers. If I tell you onion A got 5 layers, onion B got 20 layers, which onion bigger? Yeah. So therefore, the layers in an onion refer to the electron shells of an atom. So down the group, do they have more or less electron shells? Because they got more electrons. So you need more layers to fit the electrons. So the easiest example is we use lithium. Lithium has 3 electrons. So innermost 1, 2, 3. The next step is sodium. It has 12 electrons. No, it has 11. Let me see. Lithium only got 2 layers. Is this fact? Sodium has 3 layers. Is this fact? So if I go down the group, see, lithium, sodium. So this is like that. This one is you get the idea. Okay? So the answer is yes. It does increase. What? Does the number of valence electron tell me? One of those first few things we highlighted, right? Valence electron tells me the group number. So if you look at this across the period, so is the group number the same as I move from left to right? It doesn't, because it's literally 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. Therefore, so now if I stay in the same group, do they have the same number of electron shells? Same group. Same group means same what? Same group means same number of valence electrons. Look at what I drew for lithium and sodium. How many valence electrons does lithium have? Valence means outermost. 2 in the inside. Only got 1 outside. So lithium is 1 valence. Sodium also 1. So they are in the same group. Do they have the same number of shells? That's it. Same number of shells. Very good. So that's atomic number. Increase down the group across the period. What is atomic number? Yes. Atomic number is proton number. Therefore, true. Now it's all about group 1 only, which are your alkali metals. This kind, you need to remember your equations. Okay, you need to remember the equations. So when the metal react with water, will they form alkali and hydrogen gas? This is the reason why we call them alkali metals. So yes. This is exactly what I said about familiarizing yourself, and it is a yes. So if something has a low density, they will actually float on water. So when I share this kind of things with you, it's not to like, wow, must remember float on water now. No, it's to help you put a story in your head. When I drop a piece of metal into the water, it floats. Low density. Okay. High melting and boiling point is false because they actually have very low melting and boiling points. Group one means what? Group number means what? Therefore, tell me if it's group one, what does it mean? One valence electron. Very good. And metals always lose. Hence true. Will they react with oxygen to form a covalent compound? They will not form covalent. Instead, they will form ionic. Because in ionic equations, in an ionic compound, it is comprised of a metal and non-metal. When a metal and a non-metal react, they form ion compounds. Okay, it's not covalent. Then covalent is formed by what? Okay, covalent compounds are formed when non-metals react together. Okay, reactivity increases down the group. Is the arrow thing we draw just now? You flip the what you draw? Increases. Decrease up. Question say what? Decreases up. So down is increase up. Correct now. So close. Okay. Sodium has a higher melting point than potassium. Yes. The smaller it is, the higher up, the higher the melting. So back on the reactivity thing again. Rubidium is lower. So is it more or less reactive? More or less reactive. Very good. Well done, you understand already. Okay, let's go. True, false again. This one is 17. What else do we call them? So, diatomic. True, I'm going to take false, lazy. Low melting boiling point. Yes. 16. Yeah, very cool. If it's 16, it's what? Metal or non-metal? Non-metal. So, 17 is metal or non-metal? So, non-metal, non-metal for what? But we just hold on the previous page, isn't it? Hey, so it's false lah. Okay. Will they gain one electron? So 217 means what? Oh, cannot fit several electrons. Got difference not? Got difference not? The word valence. Yes. It's just like I'm wearing a jacket versus I'm wearing a jacket on the outside. The first sentence may only just mean I only want jacket, right? I never wear anything else inside. But if I'm wearing a jacket on the outside, it means that there's something else inside. They can be one shirt, two shirt, three shirt, four shirt. Doesn't matter. I got one jacket outside. So valence electrons immediately tells me, hey, I'm only telling you about what happens on the outside. Okay? What is this? Stable electronic configuration. Ariel, Claudia, Kathleen Racing, please feel free to respond as well. Very good. Because
8
stable.
electrons.
Very good. What is it? Who said that? Sorry, I didn't catch you. Can you repeat yourself, please?
8 electrons.
Very good, Arian. Thank you. It's 8 electrons. So therefore, if they have 7, how to become 8? Is to gain 1, and hence true. Wonderful, Arian. Thank you. NPBP decreases down the group is false. Color of halogen. This one, can ask you all, P6. Maybe even P5. You all do a starch test. What color is the iodine? Dark blue, Iodine is dark blue in color. Okay, yellowish brown dark blue, Okay. So if iodine is dark blue, purple even. Look at the periodic table now. If this thing is dark blue, purple, do you think it goes darker here or goes darker here? It's actually darkness below. So this one is a pale yellowish green. Okay, no. Almost colorless. Pale yellowish green, brownish, dark blue. What do you think this one is the color? The last one. Yellow. That's it. Okay, straightforward. So color intensity becomes darker down the group. Yes. Can iodine displace bromine? Remember, the big bully the small. The more reactive kicks away the less. Is iodine more reactive than bromine? No, so therefore cannot. And the last one, is chlorine more reactive than iodine? Yes. Chlorine is higher. Okay, now, what is this x minus y minus z minus? What are these? Halides are ions of halogens. How do I make sense of this? Ion. How do halogens become ions? Right here. Halogens gain one valence electron to attain stable electronic configuration. When they gain one valence electron what charge? Electron what charge? Negative. If I gain something negative, I become I gain something negative, I become positive. You become negative, then you lose something negative, it's the other way around, okay? Yes, only got lose and gain. So just remember the gain one. It makes more sense. I gain negative, become negative. So if I gain negative, I become negative. This is why they are all negative ions. Because they gain negative. That's why we don't say minus, say negative ions. They are not minus ions. Okay? But the charge, x minus, y minus, z minus. Okay? So displacement, must remember, more reactive, kick away less reactive. This one means nothing happened. Can x kick away Y minus. Yes. What does it tell me about X and Y? Is X or Y more reactive? Can kick means more reactive. X is the most reactive. Is it not? Oh, we got one. That's it. Okay. Okay, no activity. Let me change that, please. Yes. Okay, let's go. Chlorine. We start off with chlorine first. Wow, colored substance. Usually, I give you a clue. If it's gaseous and colored, it's halogen already. Okay? Then they tell me got bromide, got iodide, chlorine. Chlorine, we already know is we add here. What are the colors at P? Which is this one. When chlorine passes through potassium bromide, is chlorine going to fight potassium or chlorine fight bromine? Bromine. So who is more reactive? So chlorine can kick away bromine or not? And so when it kicks away, who is the lonely one left? You already say this one fight this one what? So potassium and chlorine now they partner. Remember, this one is the lonely one. Then this one is like that. This one can kick away this one. Therefore, they swap place. So what is here now? But there one no color. So what is left? Hey, if I want to sit in your chair, where must you go? Ah, then it's the other way lah. So this one will become kick out by itself. This one, the bromine gas. Color of bromine gas is the explanation is in part 2. So come, let's write this down. Wow, we are running out of time. Okay, come. Does it make sense now? Keep the same idea in your head. Do we have displacement reaction occurring here? So what is the gas here? What is at P? What is the gas at P? Bromine gas. When I pass Br2 into potassium iodide, can Br kick away iodide? I. Thank you, right? So what is going to be here now? If bromine kick away iodine, they still remain as bromine. Yes, Kathleen, iodine. You look at this equation. If this one is Br, this one is I. Then they swap place, ma. This one become I, what? This one become Br. So can kick or not? Very good, Kathleen. Answer is iodine. Color of iodine is Exactly the same. Can you tell me what's the answer? We write down the equation first. What is the equation? Instead of Cl2, you will say what? Br2 plus. It's the same, exactly the same. Look at the thing. What is this? So, then you look at this. Instead of 2 kBr, iodine.
Let's see that.
No more what? The C go inside here already. The Cl, not C. Then continue your equation. They swap partners. Swap. Can you follow this? There's a reason why it's like that.
Mhm. Mhm.
Yes. Very good, Kathleen. Yes. That's it. Find the pattern. Okay? Then the explanation is just change the words. Exactly it. Adrian, you want to help me again for this one? Use this to help you phrase out your answer here.
Iodine is more reactive than
Iodine more
bromine.
reactive?
Bromine more reactive than iodine. And displaces iodine to form a compound.
That displaces the ion. So it's the iodide ions from the compound, which is this one, to form the gas, which is this one. Okay, thanks for trying, Arian. All right, so use the words in green, the sentence in green to help you phrase out your answer in B part 2. Okay, oh my goodness, we only have half an hour left for the bio portions. Let's go. We will start with the nutrition portion first. Okay, so like I said, a very brief summary of what I need to know. I have pulled this out from the notes that I make for our students here, and I put it in here a little bit, and it is for you to use to familiarize yourself with, and it is for you to use as your revision. I will want to jump straight into the carbon dioxide concentration thing. I need us to understand over here, before rate of photosynthesis, as you can see, before point B, as carbon dioxide concentration increases, rate of photosynthesis also increases, as you can see in this line. Okay, but I will reach a maximum, which means that after point B, no matter how much more I add, carbon dioxide does not increase anymore. So the idea of the limiting factor is this part. When carbon dioxide increase, you also increase. This one limiting. But if I keep on increasing, no more change, no more limiting. The same idea applies for, you look at the shape of the graph, light intensity. Same idea. Okay? Because light is needed for photosynthesis, carbon dioxide is needed for photosynthesis. Now, temperature is the next one you need to learn, but the shape is very different. The most important thing I want to draw your attention to is This enzymes in photosynthesis. Always remember, photosynthesis involves enzymes. And we all learn already, right? Enzymes affected by temperature. And if you do your revision, you will recall that this is the same shape of the graph for any enzyme temperature graph. No matter what kind of enzyme, it's always this kind of shape. Okay? So therefore, let's go. Cross-section of the leaf, we need to be able to remember, identify the structures in the leaf. So when I chop the leaf in half, this is what I see. Contain chloroplast. You take the other copies. Then you're going to flip back at flower. Okay? No, that's look at the front page. Okay, contain chloroplast. Only got, I give you a clue, 3 types of cells. Well, all my options got 3 things. Must remember, I want you all to identify this layer of cells. Let's start mesophyll cells. A sheet instead. These are the spongy mesophyll cells. And finally, these are the 3 photosynthetic cells of the leaf. I hope this is a good reminder. Please remember palisade, mesophyll, spongy mesophyll, and guard cells contain chloroplast. And therefore, you're looking at two, three, six B. Okay, 236. Let's go. Percentage of stomata open. We can see that when it is dark, very little stomata open. Why will there still be stomata open? Why? Why will not be 0 open? Meaning, why will we not arrive at all the stomata close? Why will we not arrive at all the stomata close? Why is the stomata for? Transpiration. Claudia immediately jumps to that. Very good. So, Claudia, what is transpiration? Yeah, transpiration is what we're going to look at in the next one. So basically, transpiration is when the plant loses water vapor. The answer for this question I'm looking for is Right? We still take in oxygen, huh? So how? This is a true statement, but not seen in the graph. Question is asking for explains the result. So when it's brighter, the stomata open. Its light intensity increases. Is it true? Why not? When it's brighter, they open. When it's darker, they close. Sorry? So it's true, isn't it? Yeah. We have nothing about temperature in this experiment, so we cannot say anything here. This is false because as long as you have some open, some transpiration will occur already. That's it. Limiting factor, carbon dioxide concentration. Remember the shape of the graph? So therefore, when is carbon dioxide concentration limiting the rate of photosynthesis? 3 and 4, when it's no longer freezing. That's it. Okay. Okay. So if you look at the graph over here, curve A, both are done at the same 0.13, different temperature. This one is 30 degrees Celsius. This one is something we have to fill in later on. First question is just recall carbon dioxide temperature and or 3 limiting factors we learned. Question 3 is B, for those who didn't catch me just now. Welcome, Kathleen. Light intensity, absolutely, thank you. So very sure. Please don't just write down light. If you write down light, then what? Heavy. That makes sense, light intensity. Okay, so now B part 2 is what they're asking. So difference, same CO2, right? But curve A ends up here. The second curve is so much higher. So what? The second curve is 30 degrees Celsius. Curve A is higher or lower? Lower. You're gonna choose some random number. Maybe you put it at 25, too high already. Too close already.
It's so hot.
But you want to be cold. 30 degrees Celsius. Choose a big enough difference. 20 is definitely still not big enough. So maybe 10 to 15. Okay, explain. Why must be so cold? What happens when it is cold? When I talk about temperature and photosynthesis, what must I think of? We highlighted that just now. Look at the temperature one. What do you highlight?
Sorry.
Yes, enzymes. So when it's cold, what happens? Not enough energy. Okay, so we're just gonna jot this down in points because we don't have much time here. So lower temp. Enzyme substrate low energy. Decreases something. There's a very specific phrase that we need. Frequency of something. Do we recall? Okay. Now, you realize there's something missing in the graph. What is missing in our graph? Whenever you draw a graph, do you think this is a graph you will draw? What is missing in this graph?
The x-axis.
The x-axis. Wonderful. Thank you. So, rate of photosynthesis here. What is this? If carbon dioxide is listed here, temperature is listed here, this has to be light intensity. Look. Okay? In your syllabus, you only learn 3 limiting factors. That's it. Okay? Eh, okay, we ignore this one. No need to explain so long because light intensity will affect. Right? More light, more energy. That's it. Okay, let's go. Basically, we just move through very quickly. I'll pass you the answer. I'll do up an answer key for you all. Don't really have much time already. This one. Highest rate of photosynthesis. Just look at these three, right? What was the limiting factor? Is it going to be light intensity? And what light intensity was the highest rate of photosynthesis obtained is going to be 8 arbitrary. 8 arbitrary units. Oh, sorry, typo. Limiting, huh? So if light intensity is no longer limiting, what else could be limiting the rate of photosynthesis? The one of the other two lor. So it's between light intensity, what else and what else? Hmm? Temperature and carbon dioxide concentration. Temperature lor. Okay. So a limiting factor. See, we study this one. From 0.5, 0.5, the change is the 20 to 30. Do we see an increase? So therefore, this means that when I increase temperature, rate of photosynthesis will increase. So seems like temperature is limiting. Then now we look at the other one. If I maintain 30 degrees Celsius, 0.02 to 0.5, increase, right? Do we see an increase? Okay. So who is more limiting now? Is it temperature or carbon dioxide concentration? the main limiting factor will be the one that causes the most change when itself is changed. So it's going to be CO2 concentration. Okay? Let us actually go on to the next handout so that in the last 10 minutes here, I can run you through some of the more important points first. And I will send you the answers a little bit later when I have time to do out the answers. Okay, so if you look at these three diagrams here, on my screen, it is beautifully colored and clear and very sharp. So maybe you lend me your eyes on the screen. Look at it here more clearly. We need to be able to identify these structures. Okay, you need to be able to identify these structures, right? So yes, diagrams can be there as well, but these are real photomicrographs. Means the researcher used the microscope, look at it, put some dyes to color it, then take a picture, and this is what we see. So these are real ones. It's not just drawings. You need to be able to identify it because if you look at this one, it is similar but not as clear as this, isn't it? So this one is a drawing. This is an animated diagram only. Okay, please make sure we can identify and draw and identify the structures in the nice diagrams, in the not very nice diagrams, and in the real pictures. Okay, so use this to your advantage. And xylem and phloem, these we will no longer be using water and food carrying tubes. Please keep this in mind. Transports what from where to where? This one we all know already. Very importantly, is to move on to the next page here. Rate of transpiration. So this is something that Claudia mentioned just now. Transpiration. It's a loss of water vapor from the stomata. So therefore, factors that affect how fast transpiration occur will interact with the stomata. The first one we are looking at humidity, which is the amount of water vapor surrounding the plant. So if you look at this diagram here, this is my stoma. Here, got a lot more water vapor than here. So therefore, this air, low humidity, very little water vapor. Here, inside the leaf or outside more crowded. Inside, right? So very simple. Just like humans, they don't like to be crowded. So will they exit quickly or slowly? That's it. But if it's the other way around, will they want to? Okay, they can only exit, cannot enter. If here only got like 2, here got like 15, will they exit quickly or slowly? If here is 2, here is 15, exit quickly or slowly? Slowly, lor. You can only exit, I cannot enter. Okay? So therefore exit slowly. That's it. So when it's low humidity, very quickly. But the proper explanation is about our dear diffusion. So you must talk about the steep concentration gradient. Then the opposite is true, Okay, keep that in mind. Then when we look at wind speed, this one is just deeper explanations to what you have learned in P5. We all learn about air and living things and about the rate of evaporation as well, isn't it? So what happens to wind? So when the wind is still, it's not moving. Every time one water vapor comes out, it will stay here for a while first before moving away. But if the wind very strong, every time one water come out, it will get blown away. So here remains dry in a way. Here remains low humidity, which therefore you will see the same phrase coming around. Look at this. Same. Okay. Next one here, we have temperature. Temperature. This one is for evaporation. That's why you see I put 3 water droplets the same. So it's nothing to do with the amount of water vapor anymore. Because temperature is about evaporation directly. So it's about the inside. So much warmer, the water here will evaporate very quickly compared to here, only maybe 1 or 2. Then now, wow, a lot, very little. Again, concentration gradient. Whereas here, 5 versus 3. Okay lah, we'll go up a bit lah. This one is 8 versus 3. Obviously, the 8 will exit faster, right? That's exactly what we're looking at. Finally, this one is about gut cells opening and closing. But I would share that for combined science, focus more on the first few. This one, we leave it as, okay, we must make sure to be a top few students that we make sure we can get this down. Okay, so let's try some of the MCQs here, and I think that will be all the time we have here. This is to explain wilting. So what is wilting? Is wilting the plant dying? Wilting is actually the plant trying not to die. Okay, but why is it in this scenario? It is going to die if it continues like this. So when a plant is wilting, there is a window that you can save it. By doing what? Because the plant does not have enough water. That's it. We can fix something if you know what's wrong. Correct or not? So wilting means, yes, plant does not have enough water. Can you give more water lah? So if the plant does not have enough water, what happened to the plant cell? Also not enough water, right? So how do you describe a plant cell that does not have enough water?
Plasmolized.
Very good, Arian. Claudia, we use the term flaccid more for tissue or organ level, not cell level. Okay? And flaccidity is this law. Very limp. It will just droop right out. Very good, Aaron and Claudia. Thanks for the help. So we need to understand. Wow. Balloon inflated means a lot of air, and there is a netting. So I got netting, I got a balloon, and air inside. Which one explains this best? So you must understand. Air let out means not enough water. Hey, but here no water leh. Only got cell sap, cell wall, epidermis. Which one is the most relevant? Can link to water one.
Cell sap.
Excellent. Because cell sap, can think of it as your cytoplasm, contains a lot of water. So the balloon What is epidermis? If you look at all the diagrams in my notes or even your school stuff, you should see that the word epidermis means outermost. Then you look wrong. Is the balloon inside the net or the net inside the balloon? Net inside the balloon. Look at your diagram. Your diagram, what are you looking at? Your question. Your net inside the balloon or balloon inside the net? Yeah lah. So which one is the outermost thing? Is the balloon or the net outermost? Net. Therefore, net has to be the epidermis. Answer C. Okay. Okay, this one. I want you all to try because since P5, this same kind of question appears. And I can tell you right now, this kind of question got appear in P6 questions before. P6, ah? If you could do it 4 years ago, you can do it now as well. The one that changed greatest mass. Why will the leaf lose mass? What did it lose? This one tells me Claudia, leaf 3 lost the most water, means it lost the most water. What does the Vaseline do? Do you all know what Vaseline does? It's a waxy and oily layer that blocks the stomata. Okay? So if I block the stomata, just now we write down, right? What happens via the stomata? What happens through the stomata? Loss of water vapor. Then when the stomata block, can the plant lose water vapor? Cannot. So you look at this one. Lost the most water. Yes, lost the most water. Very good, Claudia. Alright, so we are looking at must be uncoated means all the stomata exposed lose a lot of water vapor. So then how? I tell you all, no need to look at this because these two same. The only difference is 2 and 4. Use this, use this. The more water you lose, the more stomata are exposed. So this one is your upper lower thing, right? Which side got more stomata? Upper or lower? Lower got more, right? If I block the lower stomata versus another one, I block upper. Which one got more stomata exposed? If this one, Paisley on upper, we write down bottom, exposed. If basically on lower line, upper exposed. Upper or lower got more stomata. So look at this one. This one will lose more water. So if you choose option C, is it correct? When leaf 4 loses more water than leaf 2? So answer is A. Agree? If basically on the upper means bottom exposed, it will lose less water and less mass than 2. Agree? Arian, Claudia, Cassie, and Racing, confused by this or not? Are we able? Okay, no, the question is, are we clear about why answer is A? Thank you, Arian, Claudia, and Kathleen. Okay, so unfortunately, that's all the time we have here for today. The chemistry portion took a little bit more time than I would have liked to. But go ahead and try the questions for the bio portion. The summary notes in front are there for you to refer to. Right, over a couple of days, I will craft up the answer key here. But I just want to share with you, if I don't get the answer key to you in time, doesn't matter. Because it's not about next week or the next 2 weeks. What are we working towards? The O levels. Correct or not? Okay. So I want to thank you for spending this 2 hours on a Thursday night with me, revising for these 2 topics for Chem and Bio. I just want to share with you that I have a Sec 4 chemistry and biology class combined already currently going on Friday nights at Coburn as well. And if you want to know more or you want to join my class straight away, if you think that I can help you learn better, please reach out to me via the chat or just text the admin. And I hope to see all of you soon. But if not, all the best for your revision. And have a good rest. Bye.
Thank you.
Welcome, Miriam.